Okay, so now we're going to get into some of the nitty-gritty here dealing with some gases. We're going to get into the gas laws. I'm going to try to make this as general and easy as possible. I'm going to give you 3 gas laws that kind of make a fourth, if you want to consider it that way, and then a couple more. But really, when it comes right down to, there's only going to be a couple of laws, thus equations, to remember. Okay, so here's some gas laws. The first is Boyle's law. Boyle, this is a little picture of Mr. Robert Boyle in the 1600s. He was the 7th son, the 14th child of Richard, the great Earl of Cork in Ireland, so an Irishman, and obviously quite a sharp tack. He went to Eton, or Eton College, when he was 8 years old. So there was Robert Boyle. And what Boyle's law says is that if the temperature remains constant, so we're ignoring temperature, if the temperature remains constant, as the pressure of a gas increases, the volume will decrease. And what we're dealing with here is basically this. We're dealing with enclosed systems. So notice that we have temperature the same. I'm going to you see it here down in the bottom. 300 degrees Celsius, both situations, the temperature is remaining constant, which is very important to remember. But notice the volume. Here we have a certain volume, and here we have a certain volume. Okay? Notice that as we increase our pressure, okay, and I'm not a real big fan of the way that they put it on this picture. I thought it was a really easy this picture to describe, but they put mass. I hate to see that as 1 kilogram. So let's go ahead and just call this 1 atmosphere, let's say. And then this one, of course, would be 2 atmospheres. It makes more sense because by definition it says if the pressure increases, the volume decreases. And so notice, as we increase the pressure on that piston, let's say, there's no place for those gas particles to go. It's an enclosed system. Then the volume is going to decrease. I mean, this is as simple as I've got that syringe again that's got a blocked exit hole here. And right now I have a certain pressure. Whoops. I have a certain pressure. If I increase my pressure, it's hard for you to see because I'm blocking it, but if I increase my pressure, then obviously the volume is decreasing. And it'll go back up obviously as I release it. Okay, so it goes to 30 cc's and there's 15. So I've doubled the pressure. So notice increasing pressure decreases the volume. And so he noticed that that was a constant. And so let's say we had a pressure of 1 atmospheres. And let's say that that volume is 20 liters. Okay, at 1 atmosphere the volume would be 20 liters. Then if the pressure, let's change this here, if the pressure would now go to 2 atmospheres, what do you think the volume would be? Well, if we've doubled our pressure, it makes sense that we've decreased our volume by half, and that's exactly the case. You can kind of see here that let's say that this was 20, then this would be 10. Okay? And so what that basically says is the pressure times the volume is equal to a constant, K. Now let me just use lowercase k as a constant. And so notice that's equal to the pressure times the volume. And again, what I'm trying to show you here is that if I took 1 atmosphere, multiplied it by 20 liters, and 2 atmospheres multiplied by 10 liters, notice that that gives me 20. And now that's not a constant like speed of light or any of these other constants that you need to know. These are just that this situation and this situation can be equal to each other. Okay, so basically I've shown you it as constants, but really the formula could then be looked at as P1 V1, the first situation, right? If we call this 1, is equal to P2 times V2. This would be the second situation. Of course, P1, V1 is multiplied together equals P2 times V2. So this right here is Boyle's law. Pressure times volume equals pressure times volume. All right, so let's see what we have here. I put it down there, and let's leave that at that for now.